There are questions about the universe that still have no answer, and perhaps they never will. Why do the laws of physics seem finely tuned to allow for life? Where do the fastest particles we have ever detected come from? And why, in such a vast cosmos, do we still not hear anyone else? This audiobook accompanies you for 2 hours on a serene journey through the deepest enigmas of space. Each piece of data is a clue, each phenomenon a reminder of how little we understand, and how much is still left to discover. The universe is an incredibly complex place, full of wonders and surprises. From black holes that devour light to galaxies spinning in a cosmic dance, every corner is filled with secrets. But why does it seem that scientists have barely scratched the surface of what is truly out there to discover? The answer to this question leads us to a fundamental dilemma. The search for answers may be more fascinating than the answers themselves. Is it possible that every answer we find opens the door to even deeper questions? Let us consider for a moment the anthropic principle, an idea that makes us wonder if the laws of the universe are designed in such a way that they allow for the existence of life. Is it a coincidence that our planet, in the midst of a hostile space, has thrived? Or is there a greater purpose behind it all? These questions invite us to reflect on the connection between the cosmos and our own existence. As we delve into these mysteries, we encounter phenomena that challenge our understanding. Gravitational waves, for example, have been detected during black hole mergers, but the ongoing presence of these waves remains an enigma. What does this mean for our understanding of time and space? Are we witnessing a phenomenon that could change everything we know? And then there are quasars, those bright objects that seem to defy our notions about energy in the early universe. How is it possible that such intense sources of light exist in a universe that, according to our theories, should be in its infancy? Each discovery in this realm leads us to rethink what we thought we knew. As we immerse ourselves in these enigmas, it is easy to get lost in the magnitude of the unknown, but it is precisely this uncertainty that fuels our curiosity. From the mystery of primordial lithium to ultra-fast cosmic rays, each question invites us to look beyond the obvious and explore the depths of the universe. What secrets do supernovae that never explode and cosmic voids that seem to challenge our understanding of matter hold for us? The cosmic silence, for its part, raises one of the most unsettling questions of all. In such a vast universe, why have we not found other civilizations? Are we alone in this immensity, or are there answers we have yet to discover? Each of these mysteries speaks not only of what is out there, but also of our own human nature, our need to explore, to understand, and to find meaning in the unknown. So join us on this journey. Throughout this video, we will unravel each of these mysteries, exploring the theories, the evidence, and above all, the fascination that drives us to keep searching. Are you ready to discover what the universe has in store for us? Because at the end of the day, each answer could just be the beginning of a new mystery. What makes the universe so special? In the vastness of the cosmos, a question looms over us. Why do the laws of the universe seem so perfectly calibrated to allow for the existence of life as we know it? This dilemma, known as the anthropic principle, leads us to explore one of the most fascinating and perplexing questions in cosmology. Imagine a universe where the physical constants are different. What would happen if the force of gravity were a little weaker or a little stronger? Or if the speed of light changed drastically? Life, as we understand it, might not exist at all. This surprising coincidence prompts us to reflect. Was the universe designed with a purpose, or are we simply here because the conditions were right? Some scientists have proposed that there may be multiple universes, each with different laws and constants. This opens up a world of possibilities. In a vast multiverse, there could be realities where life never emerged, and others where completely different forms of life developed. But how can we verify something that is, in essence, beyond our direct perception? Another approach suggests that perhaps life influences the universe in some way. By observing and measuring the cosmos, we are shaping its reality. This idea may seem philosophical, but it raises a troubling consideration. Could it be that our very existence is intertwined with the structure of the universe? However, this raises more questions than answers, and the quest for a definitive explanation remains an enigma. The precision with which the laws of physics allow for the existence of life is astonishing. For example, the electromagnetic force which holds molecules together has a specific value that is crucial for the formation of complex structures. If this value were altered, the chemistry that sustains life could collapse. Why are these constants fine-tuned in such a way? Is it pure coincidence, or is there something deeper at play? As scientists investigate this issue, they encounter an additional dilemma: the lack of definitive answers. Science, at its core, seeks patterns and explanations, but here it runs into a wall. Sometimes the questions are more intriguing than the answers. Thus, the dilemma of the anthropic principle becomes a fascinating paradox. Are we witnessing a cosmic design or merely a whim of chance? And as we reflect on this, another question arises. If the parameters of the universe are so finely tuned, does that mean we are unique in the vast cosmos? Or could there be other forms of life in places we have yet to explore? This dilemma brings us to the heart of the search for extraterrestrial life. If the universe behaves in a way that allows for life, why have we not found signs of other civilizations? The anthropic principle also has profound philosophical implications. What place do we occupy in a universe that seems so indifferent to our existence? Humanity has sought answers to its purpose since time immemorial, and the dilemma of the anthropic principle offers a new perspective on these ancient questions. Is our existence a cosmic accident or part of a greater plan? In the search for answers, scientists use string theory and other advanced physical models to try to unravel the mystery. These theories suggest that there could be additional dimensions and laws that we do not yet understand. However, each new discovery raises more questions. Are we getting closer to the truth, or are we moving further away from it? Discussions about the anthropic principle also lead us to consider the role of observation in science. Every time we measure a property of the universe, are we altering the outcome? This idea poses a dilemma that challenges our understanding of reality and the very nature of knowledge. Is it possible that, in our quest for truth, we are unable to see beyond our own existence? As we delve into the mystery of the anthropic principle, we face the reality that some questions may never have answers, but that does not mean we should stop exploring. Human curiosity drives us to seek answers, even if sometimes the journey is more revealing than the destination. Thus, the dilemma of the anthropic principle not only invites us to question the nature of the universe, but also encourages us to reflect on our own existence. What does it mean to be human in such a vast and mysterious cosmos? This search for meaning is perhaps one of the most exciting adventures in science. As we continue our exploration of the mysteries of the universe, the anthropic principle remains with us as a reminder of how little we know and how much we still have to discover. As research progresses, perhaps one day we will unravel this enigma and maybe find our answer in the far reaches of the cosmos. But until then, the dilemma of the anthropic principle will continue to be a beacon of curiosity in our endless quest for knowledge. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. What are gravitational waves, and why are they causing such a stir in the world of science? To understand this, we must first remember that the universe is a place in constant motion. Stars and black holes not only exist in space but also interact with each other in surprising ways. Can you imagine that these interactions could send waves through space-time like ripples in a pond when you throw a stone? That is exactly what gravitational waves are. Since they were first detected in 2015, gravitational waves have opened a new chapter in astronomy. But what makes them so fascinating? These waves are generated when massive objects such as black holes or neutron stars merge, creating a disturbance in the fabric of space-time. This disturbance travels at the speed of light, and when it reaches Earth, special detectors can pick up these tiny variations. But here comes the intriguing question: Could there be gravitational waves that do not come from catastrophic events, but are constant and spread throughout the universe? The answer is that we still do not know. So far, we have observed gravitational waves from events such as black hole mergers, but the idea that continuous waves might exist raises more questions than answers. What would cause them? Some theories suggest they could be the result of the activity of supermassive black holes at the centers of galaxies, but the evidence is still scarce. Imagine the possibility that these waves could tell us stories about phenomena we have not yet been able to observe directly. What secrets could they reveal about the structure and evolution of the universe? And here arises another vital question. If these waves exist, why have we not detected them in greater numbers? Gravitational waves are extremely subtle, and their detection requires advanced technology and perfect conditions. However, the fact that we have not found them continuously does not mean they are not there. It could be that our current tools are insufficient to capture the constant murmur in the background of space. What if we are one step away from a monumental discovery that would change our understanding of the cosmos? Let's think about the effect these waves would have on our view of the universe. If their continuous existence were confirmed, we would have to rethink our current theories about the dynamics of galaxies. Perhaps they would give us clues about how matter is distributed in the universe and how it evolves over billions of years. Could it be that the universe is full of vibrations that we have not yet learned to listen to? Another intriguing question is, how could we use this information? Gravitational waves could be used to explore regions of space that are invisible to our telescopes. By analyzing their patterns, we could discover celestial objects we have never seen, changing our understanding of dark matter and dark energy. The exploration of these waves could open the door to a new era in astronomy. However, not everything is that simple. Science is always full of challenges and mysteries. In this case, the lack of a unified theory that integrates general relativity and quantum mechanics makes it complicated to fully interpret the data we obtain from gravitational waves. Are we facing a new paradigm that could unite these two great branches of physics, or are we just scratching the surface of a much deeper mystery? As we advance in our understanding of gravitational waves, we also encounter the need to improve our technologies. Detection facilities like LIGO and Virgo are constantly evolving, seeking ways to be more sensitive and precise. This leads us to question, what kind of technology will be necessary in the future to capture these waves and unravel the secrets they carry? One fascinating aspect of gravitational waves is their relationship with the energy of the universe. Every time an event that generates these waves occurs, a large amount of energy is released. This leads us to wonder, how much energy has accumulated in the universe throughout its history? The waves could allow us to estimate this, giving us a new perspective on the evolution of the cosmos. Moreover, we cannot forget that the study of gravitational waves also has philosophical implications. It makes us reflect on our own existence in such a vast and complex universe. If these waves continue to challenge our expectations, could they help us understand our place in the cosmos in a way we never imagined? So, as we continue to explore this enigma, let us remember that each discovery leads us to more questions. Gravitational waves are just a part of a much larger puzzle that continues to expand. Perhaps one day, by understanding their nature, we can finally unravel some of the deepest mysteries of the universe. Are you ready to follow this exciting quest for knowledge? The adventure is just beginning. Quasars are one of the most fascinating and enigmatic phenomena in the universe. But what exactly are they? Imagine an object so incredibly bright that it can outshine the luminosity of thousands of galaxies combined. That is the essence of a quasar. But why are they so bright? The answer lies in their core, where a supermassive black hole devours matter at an impressive rate. This process generates enormous amounts of energy, which in turn emits light across various wavelengths from radio to X-rays. However, what truly intrigues scientists is how these objects can be so bright while being so far away in time and space. Let's imagine for a moment the early universe. Shortly after the Big Bang, During that period, galaxies were still forming and the environment was very different from what we know today. So how is it possible that quasars, which are so bright, existed at a time when the universe was filled with forming matter? This question opens the door to an even deeper mystery. What kind of processes took place in the primitive universe for these quasars to become so energetic? Astronomers have observed quasars that are billions of light years away from Earth, which means we are seeing the light they emitted when the universe was still young. This raises another question. How could such bright objects form in such a young universe still filled with darkness and chaos? Scientists wonder if the amount of matter available at that time was sufficient to feed these growing black holes. Could it be that quasars are showing us a phase of galactic evolution that we do not yet fully understand? One of the most puzzling aspects of quasars is their energy. Despite being so far away, their light can be detected from Earth. But what does this really mean? Is it possible that they are emitting energy in ways we have yet to comprehend? Modern physics struggles to explain how an object can be so bright from such a distance. Some researchers suggest that in addition to the matter falling into the black hole, there may be additional processes contributing to this extreme luminosity. But what are those processes? Furthermore, quasars come in a variety of shapes and sizes. Some are brighter than others, but they all share a common trait. Their light can be extremely variable. Why does this happen? Scientists have proposed that changes in luminosity may be caused by the rotation of the black hole or by interactions with nearby galaxies. But what happens when a quasar is in an environment where conditions are unusual? The existence of quasars also forces us to rethink the nature of matter and energy in the universe. What kind of materials are required to feed these black holes and make them shine like this? As we explore more about them, we realize they could be the key to understanding not only the formation of galaxies but also the evolution of the universe itself. But it's not all about formation and energy. Quasars can also provide clues about the history of the universe's expansion. As astronomers study these distant objects, they can gain insights into how the cosmos has changed over billions of years. This raises the question, what secrets do quasars tell us about the expansion and acceleration of the universe? Some theories suggest that quasars could be related to dark matter, a substance we cannot see directly, but that makes up a large part of the universe. Could these bright entities be tools for unraveling the mystery of dark matter and its influence on the formation of cosmic structures? This connection could be fundamental to understanding how the universe has been shaped as we know it. However, quasars are not just beacons of light, they are also cosmic laboratories where extreme phenomena are studied. For example, the radiation they emit can reveal information about the composition of the material surrounding them. This leads us to ask, what can we learn about matter in the universe from these observations? The answer could change our understanding of physics on both small and large scales. As telescopes advance and improve their observational capabilities, the mystery of quasars becomes more intriguing. Each new discovery raises even more questions. What else might the universe be holding regarding these bright objects? The exploration of quasars is not just a journey into the unknown, but also an invitation to rethink our place in the cosmos. In short, quasars are one of the brightest and most mysterious wonders of the universe. They confront us with questions about the nature of matter, energy, and the history of the cosmos. Every answer we find seems to open the door to more questions. And that is what makes the study of quasars an endless scientific adventure. Are you ready to continue exploring the mysteries of the universe? The search for answers has only just begun. As we approach the enigma of primordial lithium, a fascinating question arises. Why did the Big Bang, that cosmic event that gave rise to our universe, predict the existence of more lithium than we actually find today? To understand this, it is essential to remember that lithium is a fundamental element that formed in the first minutes of the universe. In those moments, the cosmos was an extremely hot and dense place, where the first atomic nuclei were formed. However, as the universe expanded and cooled, these nuclei combined to create the first atoms. It is curious to think that, according to current theories of cosmology, the Big Bang should have produced a certain amount of lithium along with hydrogen and helium, but here lies the mystery. Observations of stars and other celestial bodies show that the amount of lithium we can find in the universe is remarkably lower than predicted. Where has all that lithium gone? One theory suggests that lithium may be destroyed in nuclear processes within stars, where temperatures reach extreme levels. But is this really enough to explain the discrepancy? Imagine how many stars there are in the universe, each with its own life cycle where lithium could be consumed. However, even with this explanation, the puzzle is not completely solved. Delving deeper into the mystery, we find that lithium is an unusual element. Unlike other more abundant elements, its formation requires very specific conditions. Could there be unknown factors influencing its production or destruction? Some theories suggest that perhaps new forms of lithium are being formed in extreme cosmic events or in stellar collisions, but none of these ideas have been confirmed. Another line of investigation is based on the possibility that lithium forms in the universe differently than we believe. For example, ideas have been proposed about the existence of yet undiscovered processes that could generate lithium in significant amounts. Could it be that the universe is showing us an aspect that we have not yet fully understood? Moreover, lithium is not only important for itself, but also for what it represents in our understanding of the universe. Its scarcity leads us to question other aspects of cosmology and physics. Could this lack of lithium be a clue about the nature of dark matter or dark energy? Those mysterious forces that seem to dominate the cosmos. Scientists have been searching for answers in various places, from the interiors of stars to computer simulations modeling the primordial universe. However, despite all the advances, primordial lithium remains an enigma. Research continues, and each new observation could bring us a step closer to solving this mystery. Some theories even suggest that the lost lithium could be in regions of space that we have yet to explore. Remember that the universe is vast and largely uncharted. What secrets might be hidden in those distant corners? Perhaps there are oceans of lithium waiting to be discovered, hidden in the depths of a faraway galaxy. As astronomers have learned to observe the cosmos with greater precision, they have begun to gather data that could shed light on primordial lithium. With each new telescope, each new space mission, a window opens to the past of the universe, allowing us to look beyond what we once thought possible. But will it be enough to unravel the mystery of lithium? Technological advances have also enabled scientists to create more sophisticated models that simulate the evolution of the universe. These models can help us better understand how elements are formed and destroyed throughout cosmic history. However, even the most advanced models present discrepancies when it comes to lithium. Reflecting on all this, it is evident that the mystery of primordial lithium is a reminder of how little we know about our universe. Despite significant advances in science, fundamental questions continue to challenge us. What other secrets does the cosmos hold in its vastness? As we continue to explore, each answer we find only seems to open the door to more questions. The search for lost lithium is more than just an academic exercise. It is an invitation to keep probing the mysteries of the universe. Each discovery brings us a little closer to understanding not only the origin of the elements, but also the very history of our cosmos. In the end, the enigma of primordial lithium invites us to look up at the sky and wonder, what other secrets does the universe hold for us? The search for answers may be long and winding, but it is precisely that uncertainty that makes the exploration of the cosmos so exciting and essential for humanity. Have you ever found yourself gazing at the starry sky and wondered where those flashes of light come from? But today, we are going to explore something even more astonishing. Let's talk about ultra-fast cosmic rays. Those mysterious particles that challenge our understanding of the universe. What are they really, and why are they so intriguing? Cosmic rays are charged particles that come from space and sometimes reach Earth at speeds close to the speed of light. But here comes the most intriguing question. Where do they come from, and what does it mean that they travel at such speeds? It is believed that some of these cosmic rays may originate from supernova explosions, but there are also theories suggesting they could come from more exotic places like black holes or gamma-ray bursts. Can you imagine that an explosion billions of light years away could impact our planet? What's fascinating is that although we have detected these cosmic rays, their exact origin remains a mystery. Scientists have managed to trace some of them back to their sources, but many seem to arise from regions of the cosmos that are not fully understood. This leads us to wonder what unknown cosmic phenomena could be producing these enigmatic particles. In addition to their origin, there is the question of their energy. Some cosmic rays are so powerful that their energy is equivalent to that of a baseball thrown at over 100 kilometers per hour. How can these particles acquire such energy? This mystery leads us to speculate about forces and processes that we have yet to discover. Imagine for a moment that there are phenomena in the universe that can impart energy to these particles in ways we do not yet understand. Another intriguing aspect is how they interact with matter. When a cosmic ray collides with the Earth's atmosphere, it produces a cascade of secondary particles. But why are some of these particles so difficult to detect? Many scientists believe this could be related to how they are distributed in space and their interaction with our magnetic field. Could it be that there are more of these invisible particles lurking in the cosmos that we simply have not managed to capture? As we explore more about ultra-fast cosmic rays, we must also consider their impact on life on Earth. There are theories suggesting that these particles may affect communication systems and modern technology. Have you ever wondered if we could be exposed to dangerous levels of radiation due to these cosmic events? The answer is not straightforward, but it serves as a reminder that we live in an active and often hostile universe. As technology advances, scientists have developed increasingly sophisticated tools to study these mysteries. Observatories around the world are specifically designed to detect and analyze cosmic rays. What discoveries await us in the future? Each new technological advancement could open new doors to understanding the behavior of these particles and perhaps unveil their secrets. Cosmic rays also raise questions about the very structure of the cosmos. How are they distributed in space, and what do they tell us about dark matter and dark energy, which make up most of the universe? Every time we detect a new cosmic ray, we are challenging and expanding our knowledge about the universe and how it works. Another fascinating point is the role they play in the evolution of our planet. Some scientists suggest that cosmic rays could influence cloud formation and consequently Earth's climate. Could these particles play a role in creating conditions that favor life? The interconnectedness of these phenomena may be deeper than we imagine. And let's not forget the aspect of human curiosity. Throughout history, we have looked to the sky for answers. What else do these cosmic rays reveal about our place in the universe? The quest for answers is an innate drive of human beings, and each discovery brings us a little closer to understanding our existence in this vast cosmos. The questions posed by ultra-fast cosmic rays are many, but the answers remain elusive. In every investigation, in every experiment, a new chapter opens in our quest to understand the universe. Will these mysteries ever be unveiled? Only time and the dedication of curious minds will be able to answer this question. So, as we continue to look to the sky, let us remember that each star, each flash of light, may be a messenger of the wonders and mysteries of the universe. Ultra-fast cosmic rays are just one part of this great puzzle. As we advance in our exploration, each answer will lead us to new questions, and thus the cycle of discovery will continue. Who knows what other secrets the cosmos has in store for us? The vast universe is full of surprises, and among its most perplexing enigmas lies the mystery of failed supernovae. What happens to those stars that, according to theories, should explode in a spectacle of light and energy, but instead disappear without a trace? This phenomenon has intrigued astronomers for decades, and each new observation only adds more questions to this cosmic puzzle. To understand why these supernovae do not explode, we first need to know what exactly a supernova is. It is the death of a star, a cataclysmic event that releases a colossal amount of energy and material into space. However, not all stars follow the same path at the end of their lives. Some seem to have a different fate, a fate that we have yet to decipher. Imagine we observe a massive star at the end of its life cycle. According to current theories, it should collapse under its own gravity and detonate in a bright supernova. But in certain cases, instead, the star simply fades away. What could be happening inside these cosmic giants that leads them to such a silent end? One of the most intriguing hypotheses is the possibility that these stars become black holes before having the chance to explode. But how can that be possible? If a star collapses into a black hole, shouldn't there be some signal of its explosion? This absence of light and sound is what makes these failed supernovae an even greater enigma. Astronomers have been searching for clues to solve this mystery, and some theories suggest that the chemical composition of the star could play a key role. Stars rich in heavy elements like iron might have more difficulty releasing the energy needed for an explosion. But is this the only explanation? What other factors could influence this phenomenon? Furthermore, the internal dynamics of these stars could be more complex than we think. Certain physical processes, such as the fusion of elements, may behave differently in the final stages of a star's life. Could it be that some stars are simply fading away, transforming into something completely different before we can observe the explosion we expected? And it's not just astronomers who are facing the enigma of failed supernovae. This mystery also has implications for our understanding of the universe as a whole. By not fully understanding how and why these events occur, we are limiting our comprehension of stellar evolution and, ultimately, of the cosmos itself. But if supernovae are an essential part of the life cycle of the universe, what happens to the stars that do not fulfill their destiny? The search for answers leads us to review historical data and new discoveries. With each new observation, more questions arise. Current telescopes have uncovered patterns in the behavior of these stars that may shed light on their nature. For example, some of these failed supernovae seem to be linked to certain types of galaxies, but why these galaxies? The intriguing connection between the type of galaxy and the fate of its stars may be a key thread in unraveling this mystery. Perhaps the density of matter or the activity of star formation in these galaxies influences the behavior of stars at the end of their lives. However, much remains to be investigated and understood before we can form a clear picture. Scientists are also exploring the possibility that these failed supernovae are not errors in our theories, but rather a new category of events. If we can classify and understand these stars differently, we may be on the right path to unveiling their mystery, but will it be enough to solve the puzzle? With each new investigation, each new discovery, the mystery of failed supernovae continues to challenge our ideas about the universe. Perhaps in the future we will manage to unravel this enigma and discover not only why some stars do not explode, but also what they tell us about the very nature of the cosmos as we advance in our exploration. Let us remember that each question leads to a deeper quest, and that each mystery is an invitation to discover the unknown. What other secrets does the universe hold for us? The vast universe around us is filled with wonders and mysteries, but there is one that has intrigued astronomers for decades: cosmic voids. These enormous regions of space seem to be almost devoid of matter, raising a series of fascinating questions. Why do these gigantic empty spaces exist? What do they tell us about the structure of the universe? And most intriguingly, what is inside them? Cosmic voids are more than just empty holes in space. They are vast expanses that can span hundreds of millions of light years. To put it in perspective, if we imagine the universe as a great fabric, these voids would be the blank spaces between the threads that form the net. But how do they form? The most accepted theory suggests that they are the result of the expansion of the universe. As galaxies move away from each other, some regions are left devoid of matter, forming these voids. However, the real question is, what happens inside them? Despite their size, cosmic voids are not completely empty. They contain a surprising amount of dark matter, which is invisible and does not interact with light like normal matter does. But why is it so difficult to detect? The answer lies in the fact that dark matter does not emit radiation that we can observe, so how do we know it's there? Scientists have inferred its existence through the gravity it exerts on nearby galaxies. But there is still much to discover. What role does dark matter play in the formation and evolution of these voids? Another fascinating aspect of cosmic voids is their influence on the distribution of galaxies. It has been observed that galaxies tend to cluster in filaments and clusters, leaving large empty spaces between them. This structure suggests that the universe is not just a random collection of galaxies, but follows a more complex pattern. What does this mean for the way we understand the evolution of the universe? There is a hypothesis that, in the past, the universe was much denser, and as it expanded, these voids formed. But what is the future of these spaces? Will they continue to grow as the universe expands? Cosmic voids also have implications for the search for extraterrestrial life. In these regions, the scarcity of matter could affect the formation of new stars and, consequently, the creation of planetary systems. But does this mean there couldn't be life in those places? Not necessarily. Life could find ways to exist in environments we cannot imagine. However, the search for life becomes complicated when we consider that these voids are areas where there is less matter available to form new worlds. The exploration of cosmic voids is not limited to observation. Astronomers use computer simulations to try to understand how these spaces influence the evolution of the universe. Through these simulations, scientists can model the formation of galaxies and the distribution of matter on a large scale. But what surprising discoveries have emerged from this research? Many models suggest that voids are not just passive, but can also be engines of galaxy formation. This challenges the notion that a void is merely the absence of matter. Observations of cosmic voids have also led to questioning some of the fundamental principles of cosmology. The way these voids are distributed in the universe seems to not align with what we would expect according to current models. Could it be that there is something more at play? Some scientists suggest that understanding dark matter and dark energy, which make up most of the universe, is crucial to solving these enigmas. But what exactly are dark matter and dark energy? And how do they relate to cosmic voids? As we continue to investigate, cosmic voids serve as a reminder of how little we truly know about the universe. Every discovery we make seems to open up more questions. What other secrets do these immense empty spaces hold? As technology advances, we are getting closer to answering these questions. More powerful telescopes and advanced observation techniques will allow us to explore these mysteries more deeply. Imagine that. In the future, scientists manage to unravel the secrets hidden in cosmic voids. They could discover new forms of matter, or even better understand how dark energy behaves. But for now, we must settle for the fascination and curiosity that these spaces generate in us. The exploration of the universe is an endless journey, full of surprises and wonders. In the search for answers, cosmic voids teach us that science is a continuous process. Each mystery solved opens the door to new questions. What discoveries await us in the future? The history of astronomy is full of unexpected twists, and these voids could be the key to better understanding our place in the cosmos as we continue to observe the universe. It is essential to keep an open mind. Cosmic voids may be enigmatic, but they are also an invitation to explore. They remind us that the universe is vast and that there will always be something more to discover. With every question we ask, we take one step closer to understanding the great puzzle of the cosmos. What other wonders await us beyond these voids? Only time will tell. What if I told you that in a universe so vast, the silence is deafening? Despite the existence of billions of stars and planets, the idea that there are no signals from other civilizations is unsettling. Why, with the immensity of the cosmos at our disposal, have we not found evidence of intelligent life beyond our own planet? This mystery, known as the cosmic silence, has intrigued scientists and philosophers alike for decades. First, let's consider the magnitude of the universe. There are trillions of stars in our galaxy, and indeed, in the known universe, there are more stars than grains of sand on all the beaches of Earth. However, despite the countless opportunities for life to flourish, we have not received a single clear message from another civilization. Is it possible that we are alone in this vast ocean of stars? The search for extraterrestrial life has taken various forms over the years. We have sent probes into space, listened to the silence through radio telescopes, and even scanned the sky for radio signals. But what if advanced civilizations are simply too different from us? Perhaps they do not communicate through radio waves, or maybe their technology is so advanced that we cannot detect it with our current methods. Could it be that we need to rethink our definition of communication? The Fermi paradox is a key point in this discussion. If there are so many stars and planets, and if life develops under conditions similar to those on Earth, why have we not seen evidence of it? This question becomes an abyss of possibilities. It could be that civilizations tend to self-destruct before reaching a level of technology that allows them to communicate with others. It's a chilling thought, but we cannot ignore the history of our own planet. As we look to the future, it becomes evident that the search will not stop. Scientists continue to develop new technologies that could help us listen for echoes from other civilizations. Projects like SETI, which seeks radio signals in space, are just the beginning. But what if those signals are already present, but we simply do not know how to interpret them? There is also the dilemma of distance. The vast distances between stars mean that even if a civilization is sending messages, they could take thousands of years to reach us. Imagine receiving a signal from another civilization, but their response to our call took so long to arrive that we are no longer here to hear it. Is it possible that we are in a perpetual cycle of sending and receiving messages that never meet? The idea that we might simply not be looking in the right place is another intriguing possibility. Perhaps there are frequencies or methods of communication that we have not considered. Science has shown that the universe is a place full of surprises, and what seems impossible today could be the key to unraveling the cosmic silence in the future. At this point, it is worth asking whether silence could also be a form of protection. Some theories suggest that advanced civilizations might choose to remain silent to avoid detection by more aggressive ones. This raises a fascinating moral dilemma. Should we continue to actively seek others? Or is it better to remain in the shadows? Moreover, the cosmic silence may reflect the ephemeral nature of civilizations. If we consider that intelligent life has a limited cycle, it is possible that many civilizations have risen and fallen before we had the chance to hear them. This idea leads us to reflect on our own existence and the time we have to communicate our own story. As we explore space, we discover more and more worlds that could harbor life. However, the search for signals of intelligent life is complicated by the diversity of conditions under which life could arise. Are we looking in the right places? Perhaps life does not need water or air, but rather completely different forms of existence that we do not yet understand. The answer to the cosmic silence may be a puzzle we never solve. However, this does not mean we should stop searching. Every discovery, every new star or planet brings us a little closer to understanding our place in the universe. Human curiosity has been the driving force of our progress, and this search is an extension of that curiosity. Finally, while the silence may be discouraging, it is also a reminder of the unknown that surrounds us. We may never know why we have not found other civilizations, but the search itself is a fascinating adventure. In a universe so vast and mysterious, every question we ask brings us a little closer to understanding not only our place in the cosmos, but also the very essence of existence. So, as we continue to look to the sky, let us remember that each star is a possibility, and each silence an invitation to keep exploring. The vast immensity of the universe is home to countless secrets and wonders that we have yet to unravel. In this journey through cosmic mysteries, one of the most intriguing enigmas is the cosmic voids. What are these mysterious gaps in the fabric of space? They are regions so large that their existence leaves us with more questions than answers. Why are they there? And what do they mean for our understanding of the cosmos? Imagine an ocean of stars and galaxies in constant motion, where suddenly enormous empty spaces appear. These voids can span hundreds of millions of light years, and the surprising thing is that they are much larger than we could imagine. But why are there almost deserted areas in a universe that seems to overflow with matter? The answer to this question is complex and lies in the nooks of cosmology. Astronomers have begun to doubt the uniformity of the universe. The Big Bang Theory suggests that the cosmos expanded from an extremely dense and hot point, which should have generated a more or less homogeneous distribution of matter. However, cosmic voids challenge this idea. Could it be that matter has clustered in some way, leaving these empty regions? This phenomenon raises questions about the formation and evolution of large-scale structures in the universe. One fascinating theory is that these voids are the result of the influence of dark matter. Although we cannot see or detect it directly, we know it is present due to its gravitational effects. However, the voids seem to have less dark matter than expected, which complicates the puzzle even further. Does dark matter behave in ways we do not yet fully understand? As scientists investigate these voids, they also realize that they may offer clues about the evolution of the universe. How did they form? And what role do they play in cosmic expansion? The dynamics of these empty regions could be related to how galaxies cluster and distribute in space. As we observe more closely, we wonder if these voids are truly empty. What is inside them that we have yet to discover? The study of cosmic voids also leads us to consider the concept of dark energy. This mysterious form of energy seems to be driving the accelerated expansion of the universe. Could it be that the voids are a manifestation of this dark energy? Are they connected in some way to the phenomena we observe in the cosmos? Moreover, cosmic voids could have implications for our understanding of the large-scale structure of the universe. How do they influence galaxy formation? Computer simulations suggest that as the universe expands, matter clusters into filaments and structures, leaving voids around them. But why do some regions become denser while others remain deserted? Research on these voids also invites us to question what we know about gravity. Gravity, as we understand it, seems to be a force that affects all matter in the universe. However, the voids suggest that there may be aspects of gravity that we have yet to discover. Are there interactions we have not considered that could change our understanding of physics? As telescopes and technologies advance, the exploration of these voids becomes more detailed. Astronomers are using probes and cutting-edge telescopes to map the distribution of matter in the cosmos. What new revelations await us? The answer to this question could change our view of the universe forever. Cosmic voids are not just unexplored areas, they are windows into the past and future of the universe. Each void has its own story, and by studying them we can learn more about how the cosmos has developed over billions of years. What secrets do these blank spaces hold in the vast canvas of the universe? The possibility of other forms of life in the universe is also linked to the presence of cosmic voids. Could these uninhabited spaces indicate that life is rarer than we think? As we try to understand our place in the cosmos, the voids remind us that solitude may be an integral part of universal existence. Thus, cosmic voids offer us a rich source of mystery and reflection. As we continue to explore the universe, we are likely to discover that these empty spaces are full of potential for knowledge and understanding. What else will they reveal to us in the future? Time and human curiosity are the greatest drivers in this endless quest for answers. Ultimately, cosmic voids teach us that the most intriguing question may not be what is in the void, but why it exists. In a universe full of wonders, these deserted spaces urge us to keep searching, to keep learning, and to never stop questioning what we think we know. The path to understanding the cosmos is long, but each discovery brings us a little closer to the truth that lies hidden among the stars. What happens when we cross the boundary of what we know about physics? This is where the enigma of the Planck limit comes into play, a concept that leads us to explore the edges of our understanding of the universe. But what does the Planck limit really mean? In simple terms, it is the point at which the laws of physics as we know them cease to apply. Imagine a place in the cosmos where gravity, relativity, and quantum mechanics collide and fade into a sea of uncertainty. This is the realm where logic seems to disappear. Have you ever wondered what lies beyond that limit? The answer to this question could redefine our understanding of reality itself. At the Planck scale, everything becomes a nebulous mix of probabilities and particles that can exist and not exist at the same time. This is the result of quantum laws, where what we think we know becomes a mere whisper in the vast song of the universe. The Planck length, which is incredibly tiny, is where the structure of space and time may break down. But how did we arrive at this limit in the first place? Modern physics has tried to unite quantum mechanics and general relativity, two pillars that describe the behavior of the small and the large. However, when attempting to combine these two theories, we find that the rules change drastically at extremely small scales. When we reach that point, the predictions of conventional physics no longer work, and it is here that an abyss of unknown possibilities opens up. Why is the Planck limit so important? Because by understanding it, we could unravel some of the great mysteries of the universe, such as the very nature of gravity, or even the creation of the universe. Everything we know about the Big Bang, for example, is based on theories that crumble at this limit. What happened in that fraction of a second after the Big Bang? What laws were at play before time and space as we know them began to exist? Now imagine if we could glimpse what lies beyond that limit. Would the laws of the universe be completely different? Some scientists suggest that we might find a new type of physics, a set of rules governing the behavior of particles in that unknown realm. This idea leads us to think about the possibility of additional dimensions in a universe that is much more complex than we can perceive. Human curiosity drives us to seek answers, but what tools do we have to explore what lies beyond the Planck limit? The answer lies in particle accelerators, devices that allow us to collide particles at speeds close to the speed of light. As these particles collide, scientists hope to uncover clues that shed light on what happens at that limit. However, so far, many of these experiments have left more questions than answers. In this context, matter and energy behave in ways that challenge our intuition. Could we be living in a universe where time is just an illusion, or where the dimensions we know are only part of a much larger whole? These questions lead us to reflect on our own existence and our place in the cosmos. The Planck limit reminds us that no matter how far we advance in our understanding, there will always be a mystery waiting to be unveiled. The impact of this limit does not stop at theoretical physics. It also extends to philosophy and the way we understand reality. What does reality really mean when we reach the frontier of the unknown? Science and philosophy often intertwine in these discussions, challenging us to reconsider our beliefs and open our minds to new ideas. The search for truth in this realm is both a scientific journey and a personal one. Each discovery and each theory brings us one step closer to understanding the universe. But it also reminds us of how much we have yet to explore. The Planck limit is a reminder that knowledge is an infinite ocean, and we are merely navigators in its deep waters. As we continue our quest for answers, it is essential to keep an open mind. Science advances through curiosity and questioning. So what mysteries lie beyond the Planck limit? Perhaps we will never come to know the complete truth, but every question we ask brings us one step closer to unveiling the secrets of the cosmos. In this journey of discovery, every answer we find leads us to new questions. Are we ready to face the unknown? Human curiosity is insatiable. As we explore the Planck limit and all that it entails, we must remember that every discovery is just the beginning of a new adventure in the vast universe of the unknown. Now, as we reflect on the Planck limit, we feel a mix of awe and respect for the vastness of the universe. Every star, every galaxy, every particle we encounter in our quest for knowledge reminds us that, while science can reveal much, there will always be a mystery waiting for us, ready to be discovered. How many times have we looked up at the sky and wondered what lies beyond our understanding? In the vast universe, there are phenomena that challenge everything we know, and one of the most intriguing is blazars. But what exactly are they? Imagine a galaxy with a supermassive black hole at its core, devouring matter at an astonishing rate. This process not only generates a tremendous amount of energy, but also creates jets of particles that are ejected at speeds close to the speed of light. But why are these jets so fascinating? The answer lies in their incredible brightness. Blazars are, in fact, some of the brightest sources of energy in the universe. They can be so intense that their light can be seen billions of light years away, challenging our understanding of physics. But what drives this extreme luminosity? The key may lie in how matter is accelerated in those jets. However, science is still trying to unravel the mystery behind this acceleration. How is it possible for these particles to move at such incredible speeds? Scientists believe that the physics we know may not be sufficient to explain this phenomenon. Einstein's relativity tells us that nothing can exceed the speed of light. But when we observe blazars, we encounter particles that seem to defy this rule. So, are we facing a new paradigm of physics, or do we simply not understand the mechanisms involved? Moreover, the polarization of the light emitted by the jets of blazars provides valuable clues. By studying how light is polarized, astronomers can gain insights into the magnetic field surrounding these jets. But what does this really mean? Polarization helps us understand how matter and energy are organized in these cosmic structures, revealing secrets about their origin and evolution. As we explore more about blazars, we find that they are related to other cosmic phenomena, such as active galactic nuclei. These nuclei are like energy factories, where intense reactions occur that fuel black holes. But what role do blazars play in the evolution of the galaxies they reside in? Some scientists suggest that their activity may influence the formation of new stars in their host galaxies, creating a link between black hole activity and the life of stars. However, not everything is clear in the universe of blazars. Despite advances in the observation and study of these galaxies, many questions remain unanswered. For example, why do some black holes produce jets while others do not? The answer may lie in the amount of available matter, but this is just part of a larger puzzle that we do not yet fully understand. One fascinating aspect is the relationship between blazars and gravitational waves. These waves are disturbances in the fabric of space-time that occur when massive objects like black holes collide. Blazars could be sources of these waves, and their study could open new doors in our understanding of the universe. Are we on the verge of discovering an unexpected connection between these two phenomena? Observation technology has also advanced by leaps and bounds, allowing us to capture the light and waves from these distant blazars. This gives us the opportunity to study their content and learn more about the composition of the jets. However, with every answer we find, new questions arise. How can we use this information to better understand the universe as a whole? In this quest for answers, blazars also teach us about the nature of time and space. As the light from these objects travels toward us, it encounters the phenomenon of redshift, which means that its light shifts to longer wavelengths. This phenomenon is key to understanding the expansion of the universe. But what implications does it have for our understanding of cosmology? Blazars are also a reminder that the universe is a place full of surprises. Each discovery leads us to new and exciting questions, challenging our preconceived notions. As science advances, it is likely that more secrets about these enigmatic objects will be revealed. Are we prepared to face what is yet to come? Thus, the story of blazars is a window into the deepest mysteries of the cosmos. It invites us to keep exploring, not to settle for what we know, and to seek answers in the most unexpected places. In this journey through the universe, each discovery is a spark that illuminates the darkness of human knowledge and brings us a little closer to understanding our place in the cosmos. Therefore, as we continue to observe the starry sky, let us remember that blazars are just one of the many wonders that await us, and although we may not have all the answers now, Each question we ask is a step forward in this incredible adventure that is the exploration of the universe. What mysteries will remain to be unveiled, only time will tell. What are cosmic clocks? This question leads us to a fascinating aspect of the universe that, although it sounds like something out of science fiction, is very real and mysterious. From the farthest reaches of space, there are objects that emit regular pulses, functioning almost like cosmic chronometers. But how is this possible? Where do these pulses come from, and what do they mean for our understanding of the universe? One of the most well-known examples of these cosmic clocks is pulsars, which are extremely dense neutron stars that rotate rapidly. Imagine a sphere the size of a city, but with a mass greater than that of the Sun. As they spin, they emit beams of radiation that, when detected from Earth, appear to blink at precise intervals. But here arises an intriguing question. Why are these intervals so regular? The answer to this regularity is fascinating. Pulsars rotate at high speeds and in doing so generate a powerful magnetic field. This field acts like a cosmic beacon, projecting its light toward Earth in a specific pattern. However, not all cosmic clocks are pulsars. There are other objects that also seem to mark time in the vast universe. What about them? Quasars, for example, are another type of cosmic clock, although of a different nature. They are active galactic nuclei that emit enormous amounts of energy. Their brightness can outshine that of billions of stars combined, but their behavior over time is also of interest. Unlike pulsars, quasars can show variations in their luminosity, which raises another question. What causes these fluctuations? Astronomers have been studying these phenomena for decades, and while they have reached some conclusions, there is still much we do not know. The big question remains: what really measures time in the universe? Are the pulses of these objects the key to understanding not only time but also the very structure of the cosmos? Another interesting aspect of cosmic clocks is their utility in scientific research. Astronomers use these pulses to study the expansion of the universe. By observing the light from a pulsar and how it shifts, they can determine the speed at which it is moving away from us. But what implications does this have for our understanding of the universe as a whole? Relativity also plays a crucial role in these clocks. The way we perceive time can vary depending on the speed at which we move and the gravity we experience. This raises a series of questions about how cosmic clocks fit into current theories about time and space. Are we really measuring time in the same way in all corners of the universe? Moreover, there are objects that are not as obvious as pulsars or quasars but could also function as cosmic clocks. Supernovae, for example, when they explode, leave behind remnants that can emit radiation at regular intervals. However, the search for these hidden clocks is still in its early stages, making the mystery even more intriguing. The variability of cosmic clocks is also a fascinating topic. There are pulses that seem irregular, defying our expectations and raising questions about the very nature of time in the universe. What could be causing these changes in regularity? Could they be indicative of phenomena still unknown? As we observe space, we realize that the universe is full of surprises. Cosmic clocks are just one of the many wonders that remind us how little we know about the cosmos. Each discovery brings new questions, making the study of the universe a constantly evolving field. The implications of these objects are enormous. They help us better understand the structure of the universe and the history of its evolution. But what will happen when we finally manage to unravel all the secrets that these cosmic clocks have to offer? The answer to that question is, in itself, a mystery. As we move into the future of astronomical research, the search for these and other mysteries of the universe will continue. Every new finding about cosmic clocks could change our understanding of time, space, and how they interact with each other. Are we ready to discover what the universe has in store for us? So as we continue to explore and seek answers, let us remember that each pulsar and each quasar is more than just simple objects in the sky. They are reminders that the universe is a place full of enigmas, waiting to be solved. With each discovery, we take one step closer to understanding our place in the cosmos, and that is an exciting journey that we are just beginning to explore. Have you ever stopped to think about how extraordinary our universe is? A vast ocean of mysteries where every corner hides secrets that often seem to challenge our understanding. One of those captivating enigmas is what we know as the cosmic axis of evil. But what does this term really mean, and why should we care? In the realm of cosmology, the cosmic microwave background is the radiation that fills the universe and provides us with invaluable information about its origin. This background is like a photograph of the universe when it was very young, just after the Big Bang. However, what scientists have discovered is that in this image there is a peculiar alignment that shouldn't be there. Why is there a pattern in the cosmic background that seems to have a specific direction? The question becomes even more intriguing when we consider the magnitude of the universe, with so many galaxies and structures in the cosmos. How is it possible that there is an alignment suggesting that everything is influenced by something else? This phenomenon has led astronomers to speculate that there could be unknown forces at play, forces that compel us to rethink what we know about physics and cosmology. What could be causing this enigma? One theory suggests it might be related to the way galaxies are distributed in the universe. If there is a force affecting how these galaxies cluster or align, we could be facing a hint of something much larger than just the expansion of the universe. But what exactly is that force, and why haven't we detected it yet? The cosmic axis of evil not only raises questions about the alignment of structures in the cosmic background, but also leads us to question our understanding of time and space. If there are patterns we don't comprehend, does that mean there are aspects of the universe that we simply haven't been able to observe? This possibility is both exciting and unsettling. As we delve deeper into this mystery, we find ourselves needing to revisit some of our most fundamental theories. For example, could it be that the Big Bang was not a singular event, but the beginning of a cycle that occurs over and over again? This idea strays from the traditional notion of a universe expanding from a specific point and suggests that there is an underlying order that we have yet to discover. Furthermore, the cosmic axis of evil has implications for the search for other civilizations. If there is a pattern in the cosmic background, could it be that other civilizations have noticed it too and are trying to communicate through it? This line of thought leads us to consider whether we are looking in the wrong places or if there is simply more to the universe than we can imagine. In the realm of physics, this mystery pushes us to challenge the limits of our knowledge. Current theories about gravity, dark matter, and dark energy may not be sufficient to explain what is happening. Perhaps at the heart of this mystery lies a new physics that could revolutionize our understanding of the universe. Scientists continue to investigate the cosmic axis of evil, but every answer they find seems to open up more questions. Are we on the brink of discovering a new era in cosmology? These inquiries are the driving force that compels many astronomers and physicists to work tirelessly in their laboratories and telescopes. As technology advances, we have the opportunity to observe the cosmos in greater detail. New telescopes and space missions are specifically designed to explore these mysteries, and perhaps one day we will unravel the enigma of the cosmic axis of evil. This would help us understand not only the structure of the universe, but also our own existence within it. Reflecting on this unusual alignment, one wonders, who are we in comparison to the vastness of the cosmos? Every discovery, every unanswered question reminds us of how small we are in the vast universe. However, it also invites us to marvel and continue exploring, because every mystery solved is one step closer to a deeper understanding of our place in the universe. So while the cosmic axis of evil may be a mystery yet to be solved, it is also a reminder that the cosmos is full of surprises waiting to be discovered. With every new question, we are closer to understanding the history of the universe and perhaps ourselves. The search for answers continues, and each of us has a role in this endless exploration. The mystery of the missing baryonic matter is one of those enigmas that makes us question what we really know about the universe. What is baryonic matter, and why is it so important? Baryonic matter is the normal matter that makes up everything we see around us. Stars, planets, and even ourselves. However, surprisingly, scientists have discovered that a large portion of this matter seems to have disappeared. How can it be that a fundamental part of the cosmos is absent? Through meticulous observations and calculations, astronomers have estimated that the universe should contain more baryonic matter than we can actually detect. Where has it gone? This question has haunted researchers for decades. An intriguing aspect is that, according to current theories, the universe is composed of approximately 5% baryonic matter, 25% dark matter, and 70% dark energy. But what happens to that 5% that should be there? Is it hidden in places we have yet to explore? Several hypotheses have been proposed to explain this absence. Some theories suggest that the missing baryonic matter could be in forms that we cannot see directly. For example, it could be in extremely diffuse gas clouds distributed throughout intergalactic space where their light cannot be easily detected. However, would that be enough to explain the amount that is missing? Another possibility is that the missing baryonic matter is present in celestial bodies that we have not yet discovered. Could there be ghost stars or planets that do not emit enough light to be captured by our telescopes? This raises a fascinating question. How many unknown celestial objects could be hidden from view in the vast cosmos? Some scientists have also considered the idea that the missing baryonic matter could be in the form of primordial black holes, which formed in the early moments of the universe. But if this were true, how could we prove it? The search for these black holes and their relationship with the missing baryonic matter remains an active area of research. Moreover, the lack of detectable baryonic matter has profound implications for our understanding of the universe. If we cannot see all the matter that should exist, what does this mean for our theories about galaxy formation and the evolution of the cosmos? It could be an indication that we need to revise our current theories and models of physics. In the realm of cosmology, the missing baryonic matter also raises questions about the nature of dark matter. If part of what we consider dark matter turns out to be undetected baryonic matter, this could radically change our understanding of how the universe works. Are we really seeing the complete picture or just a fragment of it? Advancements in technology and observation have allowed astronomers to explore the cosmos in greater detail than ever before. With more powerful telescopes and innovative techniques, the search for missing baryonic matter may be closer to an answer. But how much longer will it take to solve this cosmic mystery? The fact that we still cannot fully explain the missing baryonic matter reminds us of how little we truly understand about the universe. Each discovery brings new questions, and each answer seems to open the door to more enigmas. That is the beauty of science. The pursuit of truth is constantly evolving. As we continue to investigate, we may eventually find the baryonic matter we believe is lost, or perhaps we will discover something completely unexpected that changes our perspective on the universe. In any case, what is clear is that the journey toward knowledge is far from over. So the next time you look up at the starry sky, remember that there is a hidden mystery still waiting to be solved. The missing baryonic matter is just one of the many unknowns that challenge us to keep exploring. Keep questioning and keep marveling at the vastness of the cosmos. The search for answers is a fascinating journey, and every step we take brings us a little closer to unraveling the secrets of the universe. What if I told you that there are galaxies in the universe that seem to challenge all our theories about dark matter? These galaxies have been observed without the presence of this mysterious substance that, according to our models, should always be around them. But how can this be possible? What does it really mean for our understanding of the cosmos? Dark matter is fundamental to explaining how galaxies move and how they group into larger structures. It is believed to represent about 95% of the universe. However, it has never been observed directly. Scientists have inferred its existence from the gravitational effects it seems to have on visible matter. But what if some galaxies exist without it? What does that tell us about what we think we know? An intriguing example is the galaxy known as NGC 3095. This object is located about 50 million light-years away from Earth and, despite being a spiral galaxy, does not show the typical signs of dark matter. The stars and gas within it seem to behave differently than what current theories predict, but is it possible that we have been looking in the wrong direction? As astronomers take a closer look at these dark matter-free galaxies, new questions arise. Could these galaxies be an indication that different types of matter or forces exist that we have yet to discover? Or perhaps they are simply a rarity of the universe, an anomaly that does not fit our models. Each new galaxy found without dark matter challenges the traditional narrative of how we think the cosmos works. We also wonder, what does this mean for our understanding of galactic evolution? If some galaxies can exist without this mysterious matter, could they have developed their structures in unique and distinct ways? Perhaps these galaxies have found alternative ways to form stars and maintain their cohesion. This idea opens up a range of possibilities about how the forces we know might not be the only ones shaping the universe. Another intriguing question is the implication this has for cosmology itself. If dark matter-free galaxies are more common than we think, perhaps we need to reconsider how we map the universe and how we understand its history. Could it be that dark matter is not as ubiquitous as we have believed? Are we on the brink of a revolution in our understanding of the physics of the cosmos? Let us also consider the role of observation. As technologies advance, modern telescopes are capable of seeing farther and clearer than ever before. This allows us to discover galaxies that would have previously gone unnoticed. What other secrets are waiting to be revealed in the darkest and most distant corners of the universe? Each new discovery has the potential to rewrite the textbooks of astronomy. Some scientists suggest that dark matter-free galaxies could provide clues about how the universe formed. These galaxies might be remnants of past epochs, where conditions were different, but could we learn from them to better understand the present and future of the cosmos? Exploring these questions could lead us to surprising answers and perhaps to new theories that challenge everything we know. The scientific community is divided on how to interpret these findings. Some believe that these galaxies are the result of unique gravitational interactions, while others think they could be the beginning of a new era in physics. What path will research take in the coming years? We will have to stay tuned for the advancements that may arise in future studies. The search for answers about dark matter-free galaxies is not only a fascinating puzzle but also reflects our innate curiosity about the universe. Each new answer generates more questions, and thus the cycle continues. How many more mysteries await us in the vastness of the cosmos? What other surprises lie on the horizon of our astronomical exploration? As we continue to investigate, the hope is that one day we can unravel these mysteries. Perhaps the key to understanding dark matter and its relationship with the rest of the universe lies in these unusual places. Science progresses, and with it, our tools and theories. Are we ready to accept that our understanding of the universe may change radically? So as we keep looking up at the sky, let us remember that the universe is a place full of surprises. Every star, every galaxy, every mystery invites us to learn more. The absence of dark matter in some galaxies may be just the tip of the iceberg of a deeper knowledge about the cosmos. Who knows what other secrets lie hidden in the darkness of space, waiting to be discovered by those who dare to ask. With each new revelation, we get a little closer to unraveling the great mystery of the universe. Human curiosity is a powerful engine, and as long as we keep exploring, there will always be more to discover. This is how we move forward, one step at a time, on this endless journey toward knowledge. What are neutrinos and why are they so intriguing? This small and almost undetectable traveler of the cosmos may seem insignificant, but in reality, it is one of the most abundant particles in the universe. Imagine that there are trillions of neutrinos passing through your body at this very moment without you even noticing. How is it possible that something so elusive and light can have an impact on our understanding of the universe? Neutrinos are subatomic particles that have an extremely small mass and, surprisingly, hardly interact with matter. This means they can pass through entire planets without leaving a trace. But what does this imply for science? Physicists have discovered that these ghosts can provide clues about distant cosmic events and the fundamental properties of the universe. However, despite their abundance, they remain an enigma. Why is it so difficult to detect them? The story of neutrinos begins in the 1930s. At that time, physicist Wolfgang Pauli proposed the existence of this particle as a solution to a problem in nuclear physics. Since then, scientists have been racing to understand their mysteries. What secrets do neutrinos hold? In reality, they are more than just simple particles. They are messengers of cosmic phenomena such as supernova explosions and fusion in the cores of stars. At the heart of a star, where nuclear reactions occur, enormous amounts of neutrinos are generated. In a supernova, for example, trillions of neutrinos can be released in a single second. However, most of them pass through the Earth undetected. What would they tell us if we could catch them? The answer could lie in the very nature of matter and energy in the universe, and here lies the dilemma. Although sophisticated detectors have been built in places like the bottoms of lakes or deep mines, these devices are extremely sensitive and still only manage to capture a tiny fraction of the neutrinos that pass through us. Why is it so complicated? The answer lies in their elusive nature. Unlike other particles, neutrinos do not produce significant rebounds or interactions with matter, making their detection a monumental challenge. Scientists have begun to discover different types of neutrinos, adding more layers to their mystery. There are three flavors: electron neutrinos, muon neutrinos, and tau neutrinos. Each of them has unique properties and is generated in different astrophysical processes. But why this variety? What does it tell us about the structure of the universe? The existence of these differences could have implications for how the fundamental forces that govern our cosmos work. One of the most fascinating aspects of neutrinos is their ability to oscillate, meaning they can change from one type to another as they travel. This phenomenon has led scientists to consider new theories about physics beyond the standard model. Could neutrinos be the key to understanding dark matter? This question has intrigued generations of physicists, as it is believed that a significant part of the universe is made up of matter that we cannot see or detect directly. Imagine that neutrinos are like a bridge between the known and the unknown. By studying these cosmic messengers, scientists hope to unravel the secrets of the universe, from the formation of galaxies to the nature of dark matter. But how far can we go in our quest for answers? Each discovery about neutrinos opens a new window into understanding the cosmos. And while we have made significant progress, there is still a long way to go. Research on neutrinos remains an expanding field. New experiments and technologies are underway, seeking to unveil their secrets. What surprises does the future hold for us? Each new finding could change our understanding of physics and potentially the very structure of the universe. As we delve deeper into the study of neutrinos, we also face philosophical questions. What does it mean for humanity that there are particles that elude our capacity for observation? It reminds us of how little we truly know about the vastness of the universe. Each answer brings more questions, and each discovery leads us to a new mystery. On this journey through the cosmos, neutrinos offer us a glimpse of what lies beyond our current understanding. With each new advance, we may be closer to understanding how the universe was formed, how it works, and perhaps even if we are alone in it. Are neutrinos the key to unlocking the secrets of the cosmos, or are they simply guiding us toward new questions? In summary, neutrinos are more than particles lost in the vast universe. They are a reminder that knowledge is infinite and that each answer can lead us to new unknowns. The quest for the truth about neutrinos is an ongoing scientific adventure. And who knows, perhaps in the future we will come to understand this enigma that silently accompanies us on our journey through the universe. What if I told you that there is an era of the universe that we have never been able to see directly? A time when there was no light, a period when everything was dark and mysterious. This period is known as the early dark universe, and it is one of the great enigmas that scientists are trying to solve. How was it possible for the universe to exist without light? What kind of matter and energy were present at that time? The early dark universe encompasses the first moments after the Big Bang, when the cosmos was still in its infancy. During that time, the universe was extremely hot and dense, filled with particles that had not yet combined to form atoms. But what happened next? Over time, as the universe expanded and cooled, particles began to join together, forming the first atoms. But before that happened, there was no light, only darkness. It's a very intriguing mystery, don't you think? Now imagine for a moment what it would be like to exist in a completely dark universe. No stars shining in the sky, no warmth from sunlight, just a vast sea of emptiness. But how do we know that this stage existed? Scientists have turned to theory and indirect observation to infer what happened during those early moments. Through mathematical models and simulations, they attempt to reconstruct the cosmic landscape of that time. One of the keys to understanding the early dark universe is the cosmic microwave background radiation, which is like an echo of the Big Bang. This radiation provides us with clues about what the universe was like in its earliest moments. However, we have not yet been able to directly observe what occurred during that stage. The light that could have given us answers has been lost to time. So, what other evidence do we have? Computer simulations are powerful tools in this case. Scientists can recreate the conditions of the early universe, testing different scenarios and seeing which one fits best with what we observe today. But the question always remains, are we interpreting the data correctly? Could there be more than what we see? The answers are not easy to find, and that is what makes this mystery so fascinating. Another intriguing aspect of the early dark universe is the formation of the first structures. While light was absent, it is believed that small fluctuations in the density of matter began to collapse, forming the first galaxies and stars. But how did these structures form without the light we normally associate with star creation? This raises questions about the processes that shaped our universe. Astrophysicists are also interested in the nature of matter during this dark era. At a time when the universe was so dense, the interactions between particles must have been very different from what we observe today. But what does this mean for our understanding of physics? Could there be laws that we do not yet comprehend? As we delve deeper into these mysteries, we find more questions than answers. One of the challenges in studying the early dark universe is the lack of light. Everything we know comes from indirect observations and theories. Could it be possible that in the not-too-distant future we find a way to observe that period? Technology is advancing rapidly, and each new telescope launched into space brings us a little closer to unraveling these cosmic secrets. Imagine that those first moments of the universe are waiting to be discovered, like an ancient book full of wisdom. Each page we turn reveals more about how everything began, but can we trust that current theories are correct? As new discoveries are made, theories must be revised and adapted. Science is a constantly evolving process, and the early dark universe is a fertile ground for new ideas. The search for evidence about the early dark universe has also led to the creation of laboratory experiments. Some scientists are trying to recreate the conditions that might have existed during those moments, seeking answers in subatomic particles. But can they really capture the essence of what happened in the cosmos? The answer to that question remains a mystery. The early dark universe forces us to rethink our understanding of creation and existence. If we cannot see what occurred, how can we be sure that it really happened? This is where philosophy and science intersect. The quest for the truth about our origins is a journey that goes beyond mere observation. It invites us to question our own existence and the place we occupy in the vast cosmos. Each discovery in this field brings us a little closer to understanding not only the universe but also ourselves. Human curiosity is what drives us to keep investigating, to keep searching for answers. The early dark universe is just one piece of a much larger puzzle, a puzzle that continues to expand as we explore the depths of the cosmos. As technology advances and our tools become more sophisticated, the future of research on the early dark universe brightens. What mysteries will it reveal? What new questions will arise as we venture into the unknown? The search never ends, and that is what makes the exploration of the universe so exciting. So as you contemplate the vast universe, remember that there is much more than what we can see. The early dark universe is just one of the many mysteries that await us. And each discovery can change our understanding of reality. Darkness in this case is not absence, but an invitation to explore the unknown and embrace the curiosity that defines us as human beings. How do galaxies form? What role do black holes play in this incredible cosmic dance? The answers to these questions are not simple, as black holes, those mysterious objects of the universe, have a deeper influence than we might imagine. Black holes are not just star devourers, they are also true architects of the cosmos. From their birth, in the hearts of massive stars that have reached the end of their lives, these gravitational monsters can affect the surrounding galaxies in astonishing ways. But how do they do it? First, let's consider the force of gravity. A supermassive black hole found at the center of nearly all galaxies exerts a powerful attraction on the stars and gas around it. This gravitational pull can influence the formation of new stars. If there is enough material, the black hole can compress it until new stars are formed, thus feeding the galactic life cycle. But what happens when a black hole encounters a growing galaxy? When one galaxy merges with another, the black holes can also come together, creating an even more massive one. This process not only leads to the creation of new stars, but can also destabilize the entire galaxy. Interactions between black holes and stars can cause some of them to be ejected at high speeds, while others are drawn toward the center, where the black hole may devour them. Isn't it fascinating to think that the fate of stars may rest in the hands of a black hole? Moreover, black holes can influence the shape of the galaxy itself. In elliptical galaxies, where stars are older and less active, the presence of a supermassive black hole can help maintain the structure and stability of the galaxy. However, in spiral galaxies, its effect is different. The rotation of the galaxy and the attraction of its black hole can create star formation patterns that are visible in the form of spiral arms. An intriguing aspect of black holes is how they affect the galactic environment. When black holes consume matter, they release enormous amounts of energy in the form of radiation. This not only heats the surrounding gas, but can also influence the formation of new stars. The energy released can create bubbles of hot gas, which in turn can inhibit or stimulate the creation of new stars. Could it be that the existence of black holes has been key in the formation of galaxies as we know them? The influence of black holes on galactic evolution doesn't stop there. They are also related to the activity of quasars, those extremely bright objects found at the center of some galaxies. These quasars feed on material falling into the black hole, and their luminosity can reach unimaginable levels. In this sense, black holes not only shape galaxies, but can also illuminate the universe, revealing its history and evolution. However, despite their importance, many questions remain unanswered. What exactly happens at the heart of a black hole? How does its presence affect the dark matter surrounding galaxies? Research on these topics is ongoing, and each new discovery can change our understanding of the universe. Additionally, black holes may be related to even stranger phenomena, such as dark matter and dark energy. Could black holes be the key to unraveling these mysteries? Perhaps their influence extends beyond what we can see and measure. Technological advancements allow us to explore the cosmos in ways that were previously unthinkable. With more powerful telescopes and innovative observation techniques, astronomers are beginning to unveil the secrets of black holes and their role in galactic evolution. Each new image and piece of data brings us closer to understanding how these objects have shaped the universe over time. Let's imagine for a moment a future where we can observe and understand the interaction of black holes with their environment in real time. How would this change our perception of the universe? The possibility of witnessing the dance of galaxies and their black holes could reveal patterns and connections we have yet to imagine. As we continue to explore the universe, it is essential to remember that black holes are just one part of the puzzle. Each discovery brings us one step closer to understanding the vast and complex network of interactions that form our cosmos. Astronomical research remains an exciting adventure, and every question we answer generates new uncertainties. In conclusion, black holes are not just isolated entities in space, they are fundamental pieces in the puzzle of galactic evolution. Their influence, from star formation to the structure of galaxies, invites us to reflect on the role they play in the cosmos. As we advance in our quest for knowledge, black holes will continue to be a captivating mystery, challenging us to explore beyond what we know and to question what still remains to be discovered. What do we really know about the vast universe that surrounds us? Looking up at the starry sky, we find more questions than answers. Why are we here? What is our place in this immensity? Each discovery in astronomy only opens new enigmas, challenging our understanding of reality. From dark matter to dark energy, every element of the cosmos seems shrouded in a veil of mystery. But why is this so? Could it be that the universe is inviting us to decipher its secrets? The search for answers leads us to reflect on humanity's role in this grand scheme. As we observe the wonders of the cosmos, we ask ourselves, are we just a cosmic accident, or is there a purpose behind our existence? Science offers us tools to explore these questions, but each answer often leads to a new puzzle. This endless cycle of discovery and wonder is what makes the exploration of the universe so fascinating. So, what does the future hold for us in this never-ending quest? As we improve our technologies and expand our horizons, we may be closer to unraveling some of these mysteries, but is it possible that in our quest for understanding, we might even question the very foundations of what we think we know? Science progresses, but with each step we face the reality that we are still newcomers on the vast stage of the universe. When we look to the future, there are questions that linger in the air. Will there be other civilizations waiting to be discovered? What if we find intelligent life in another corner of the universe? It would be a historic moment that would change our perspective on life itself. But it could also give rise to new ethical and philosophical dilemmas. The possibility of not being alone in the cosmos invites us to contemplate our role within it. On our path to knowledge, it is important to remember that every mystery we solve also reveals others. The search for dark matter, for example, has led us to explore concepts that once seemed unimaginable. What is dark matter really, and how does it affect our understanding of the universe? This is a puzzle that still challenges us and drives us to continue investigating. The history of humanity is intrinsically linked to exploration and discovery. Have we ever been as close to understanding the cosmos as we are now? Every new telescope we launch into space and every experiment we conduct on solid ground are steps forward in a journey that never ends. But will it be enough? Are we prepared for the revelations that could change our understanding of the universe? In our quest, we must also consider what is at stake. What if our discoveries reveal that the universe is a much stranger and more complicated place than we imagined? The possibility that there are forces and phenomena beyond our current understanding can be frightening, but it is also exhilarating. Human curiosity is a powerful engine, and it is that same curiosity that drives us to move forward. The questions we pose today may not have immediate answers, but that does not mean we should give up. Each generation of scientists and thinkers has left its mark on the path to knowledge, and we are part of that ongoing search. So, what legacy will we leave? How will we influence future generations of explorers and dreamers? As we reflect on these mysteries, it is essential to remember that every answer we find is just a part of the puzzle. Science is a journey, not a destination, and although some of these enigmas may remain unanswered for a long time, each attempt to understand them brings us a little closer to the truth. Isn't this the true spirit of exploration? The vastness of the universe is full of surprises, and each day offers us new opportunities to learn. The next time you look at the sky, think about the infinite possibilities that unfold before us. How many lives have been lost in the pursuit of these mysteries? How many more will join the cause? The history of the universe is a story of discovery, and each chapter is as intriguing as the last. As we conclude this reflection on the mysteries of the universe, it is essential to keep the spark of curiosity alive. What mysteries do you hope will be revealed in the future? Science and exploration continue to advance, and each of us has a role to play in this cosmic epic. So, are you ready to keep exploring? The universe has much to offer, and the questions that remain to be answered are infinite. Who knows what discoveries await us on the horizon?